Next, we look into selective repeat sliding window protocol. So the drawback of go back N we have seen, or I would like write like this: go back N. I'll write in short. Go back N will be performing better, or works will be performing better. Will be performing better if errors are less or rare. Errors are rare. But if the channel communication link, the channel or the line is poor, then it wastes a lot of bandwidth. It wastes a lot of bandwidth due to heavy retransmissions. Is it not? We have seen that in the previous video. Please recollect that. Heavy retransmissions. So therefore, selective repeat overcomes this problem by having larger window size at receiver. But having larger window size at the receiver also implies that receiver needs to have more buffers. So therefore, this will become more complex and costly, and also costly. So point is, sender window will be greater than 1. The receiver window will also be greater than 1. What is the maximum value it can have? Like for example, I'll assume again I'm using n-bit sequence number. Right? The maximum value I can have is 2 power n minus 1. 2 power n minus 1. Like if I take n is equal to 3. Total number of sequence numbers are 8. Numbered sequentially 0 to 7. That's what I wrote. 2 power n minus 1. Is it not? So 7 is 2 power 3 minus 1. This is called maximum sequence number. This is called maximum sequence number 7. Maximum sequence number. Right? So sender window can be 8. Receiver window can also be 8. So this fellow will need 8 buffers. This fellow will also need 8 buffers. But the advantage here, because I have multiple buffers, so this implies that receiver can accept out of order frames. That means like earlier occasion, window size of receiver was 1, so therefore it was discarding the frames. But here, because I have multiple buffers available, so it can accept the frame. To illustrate that point, I will show the presentation. Please follow me. So what is the drawback, the trade-off made for go back N? Simple strategy for receiver, needs only 1 frame at it, but that will waste the bandwidth. I have already told you. So look at selective repeat, what is happening. The same scenario now, this is a sender, is a receiver. Okay. Cumulative acknowledgement indicates highest in order frame receive, and NAK means negative acknowledgement. So like earlier occasion, it sends 0 accept, 1 accept, 2 was in error. But here receiver window size is greater than 1, so it is accepting 3, 4, 5. Earlier this was not getting accepted. Now it is getting accepted because the window size of the receiver is more than 1. It has sufficient buffer. Then 2 is retransmitted accept. So 2 got, here we are sending the negative acknowledgement for 2. Please observe, negative acknowledgement for 2. 2 is in error. So 2 is retransmitted. Then again it is after that, since it has already received 3, 4, 5, it is sending cumulative acknowledgement 5. Then immediately it has already sent 2 after that, because it got 5. So it's 6. After send retransmitting 2, 3 has not retransmitted. So it will send 6, 7, 8. It keeps on accepting because it has already got 5. So therefore it has rotated the receiver window size to 6, 7 and 8, and then continuously to accept, and like that it goes. So here the efficiency will be much higher than in comparison to the previous protocol, but the complexity of this will also be high. The complexity is more of buffer management. I need more buffers, so that makes it more complex. Okay, so more complex than go back end due to buffering at the receiver and multiple timers at the sender. More efficient use of link bandwidth as only lost frames are retransmitted. This is the advantage of this protocol, right? So this is all about the sliding window protocol, right? All about the sliding window protocol, the three protocols we have seen. But here I need to make you understand one important aspect: what could be the actual window sizes of sender and receiver. Okay, to illustrate that, I take this slide. Please follow me carefully. What can be the maximum window size? Like if I use a 3-bit sequence number, then I said I can have, say for example, 0 to 7. But as we said in go back end, we have to take -1. So therefore I'm taking -1. Means with 3-bit sequence number, so let me write, with 3-bit sequence number, the maximum number of sequence numbers I can have 8, 0 to 7. But as I said, the window size of the sender cannot be more than, 8 cannot be 8 if we take 7, right? So therefore 0 to 6. So that's why this is a sender window for 0 to 6. It sends all the 6 frames. All the 6 frames have been accepted and retransmission and the acknowledgement sent. Acknowledgement is sent. Okay? Acknowledgement is sent. But imagine that acknowledgement is lost. Acknowledgement is lost. So what is going to happen? After, because it has sent, the receiver has sent the acknowledgement for 6. So therefore it will rotate the window, slide the window to the size of next 7. So starting from 7, 0, 1, 2, 3, 4, 5. This will be the next window size. So 7, 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 7 frame. Right? Window size is 7. So it is slided from 7 back to 0, 1, 2, 3, 4, 5. So these are next new set of frame that it is expecting because it has sent the acknowledgement. But these are retransmissions. Why acknowledgements, I said, are lost? Either cumulative acknowledgement or the final acknowledgement is lost. So since sender has not received the acknowledgements of its previously transmitted frame, so it will retransmit all 0 to 6. So what happens? Among 0 to 6, only 6 is not present in the current window of receiver. Remaining all are present. So accidentally or erroneously, it will accept. Why? Because this is overlapping. This is a new window of receiver. This is the old window of the sender. It overlaps. So the new window overlaps with old window of the sender. This should not happen. So these are the new frame that receiver is expecting. These are the old frame that it has transmitted. So mistakenly it accepts because of this overlap. So to avoid that overlap, what we say is there should not, when it slides a window, the new frames that it is expecting should not overlap with the previous one. So for that we have to reduce it by half. So what shall we do? See, the total correct value is this. Half of it become 4, right? 8 by 4. Total number of sequence numbers 8. Half of it become 4. So if initially sender send the same scenario, now if I take, if the sender sends 0 to 3, original accepted, acknowledgement lost. So after that it has slided now. Receiver has slided to 4, 5, 6, 7. This is a new frame that it is expecting. Why? Because it has lost. Now because acknowledgements have been lost, so it will retransmit like earlier occasion, 0, 1, 2, 3. But 0, 1, 2, 3 are not present here. So they will not be accepted. They will be simply rejected. And this fellow acknowledgement will also have timer, will again send the acknowledgement for 3. Now when it comes, it will slide and then it will transmit to accept. So therefore, the simple point is, what is the simple point? In the case of selective, I will write it in the new slide. In selective repeat, SRP, the sender and receiver should not have overlap windows after sliding, not before. Hence, to overcome this overlapping windows as I shown earlier, Suppose if I say n represents, look at the formula, number of bits in sequence number, number of bits in sequence number, and let us say total, capital N indicate total number of sequence numbers, which is equal to nothing but 2 power n, right? So the value of W as derived from previous equation was 2 power n minus 1, right, which is nothing but n minus 1. Like in our example it was 7, but still it cannot be, this cannot be, as we seen, it can lead to overlap. So therefore what we say is the maximum window size of sender and receiver should be half of total sequence numbers. That is nothing but, so window sizes, I write window size WS is equal to sender and receiver is equal to half of 2 power n, which we can write it as n by 2. This can also be written as maximum sequence number that I can represent, which is nothing but, if I take n equal to 3, 7. So maximum sequence number plus 1 by 2 is the answer. Like if I take n is equal to 3, the total number of sequence numbers n are 8. So the window size of the sender and window size of the receiver should be 8 by 4, 8 by 2, which is 4. So it should start like 0, 1, 2, 3, and receiver will also start like 0, 1, 2, 3. I'll go to the next slide. So sender will start with window 0, 1, 2, 3. Receiver will also start with 0, 1, 2, 3. Okay. So suppose if it sends all of them, arrives at the other side, acknowledgement sent, then after acknowledgement is sent, it will slide the window next to 4, 5, 6, 7. So now this slided is not overlapping with sender 0, 1, 2, 3. It is not overlapping. So even if this acknowledgement not overlapping, even if this acknowledgement is lost, it will transmit 0. 0 is not falling, so it won't accept. It will reject it. There's the advantage of selective repeat. Okay. So this is the sliding window protocols. Okay. So make a study of this, watch the video multiple times and make a thorough study. And these are all 5-mark questions, and also you have to implement them in the lab. All right. So next we will look into the next chapter, medium access layer, in the next video.